So in this section, section 3.3, we'll be learning all the different ways to subtract whole numbers. So for these models of subtraction, remember subtraction really is just undoing our addition. Subtracting and adding are sometimes called inverse operations. Some students have a really hard time understanding how to undo stuff, so we will discuss it in these ways. We're going to model it using takeaway, missing add in, comparison, and the number line. So our takeaway strategy in subtraction is just that. You have a bunch of blocks with your students and you just take these out. Take them away. So we had 8, we took 3 away. Now let's count, and we have 5 left. So that's called the takeaway strategy. So the next strategy is called the missing add-in. Sort of think of it as what is behind curtain number 1. So we're going to have the way we show it somewhat abstractly is with that box right there. 3 plus something equals 5. So think of putting a Kleenex or a curtain, something over several blocks. So you could set out 8 blocks and then cover up 5 of them. And then say, oh, there's 3. I'm telling you there's 8, so how many is left? So that's called the missing add-in. We also have our number line. So with our number line, we're going to go 8 out, and then we're saying, okay, well, we went 8 out. Now we've gone 3 out, so if we subtract those 3, let's see, how far is it from here to here? And that would be 5. So that's a way to do that using a number line. Go out 8 and then use another arrow to go out 3 and see what the difference is. So in subtraction, students are introduced to the idea of something that's not known, an unknown. That's actually an algebra concept. Notice this is in grade 3, and they're starting to use question marks or blocks, okay? So that's just introducing that unknown. Now, in subtraction, I want you to think of this definition. For any whole numbers A and B, so that your A is actually the biggest number. When you take A, subtract B, you're going to get an answer. And that answer, you could add that to the other number and get the one you started with. So one way you could think of that is this. 8, 3, and 5. So I could add these guys. I could add 3 plus 5 and get 8, but I could also subtract. So 8 minus 3 equals 5. That's our subtraction. Or you could think of it as 3 plus 5 equals 8. This is called a fact family, and we'll talk about that a lot more later. Anyway, so the comparison strategy is essentially what we did with this number line. Okay, except we're going to use blocks. So Juan has 8 blocks, so we lay out his 8 blocks. And Susan has 3 blocks, so we lay out her blocks. And then we look to see what the difference is. And you say, oh, Juan's got 5 more blocks than Susan does. That's just where you compare 2 numbers using blocks. Then we have this number line strategy. And in this one, you're going to go 5 in the positive direction, and you're going to subtract 3. So you're going to come back 3 and then just see where you wound up. And we wound up at 2. So that is another number line strategy that you could use for subtraction. So remember, we talked about a whole bunch of addition properties: closure, commutative, associative, and identity. So let's see how those work in subtraction. So first, let's look at our closure property. So I'm going to pick out a couple of numbers, like 5 and 10. When I subtract, Notice I get a -5. Well, -5 is not a whole number. So if we had our little box and the only thing we had in our box were positive numbers, then when we subtract two positive numbers, notice that 10 is bigger than 5. So that is why it's not a whole number. So closure doesn't work. Let's check out our commutative property. So here we have 10 minus 5, or 5 minus 10. We just switched these guys. I took that one and move it here, and take this one and move it here. That's called the commutative property. On this side, I get 5, but when I flipped them, commuted them, I got -5. So the commutative property doesn't work for subtraction. Let's try the associative property. So associative, remember, that's just how you group things. So notice these are in the right order. These are in the same order: 5, 4, and 3. And over here, 5, 4, and 3. But I'm going to group these guys first. So 4 minus 3 is 1. And then 5 minus 1 gives me 4. But over here, if I group these guys first, then that gives me a 1. And 1 minus 3 gives me -2. Those guys are not the same. So the associative property doesn't work with subtraction. Let's do the identity. That's where you get the same thing you started with. So 5 minus 0, now that works, right? That looks like, okay, the identity property is going to work. But once again, when I switch these and put that one there and then put this one here, now I get a -5, which is not the same thing I started with. So the identity property doesn't work. So none of those properties, none of those laws work for subtraction. That's why you have to really watch out what order you put your numbers in, because of commutative property, and where you put your parentheses because of associative property. Okay, so now we're going to plug in some X's. Instead of using the box, now we're going to put in an actual variable. We're going to stick our X in. Students completely freak out when you put an X in. I remember talking with my sister. She's 7 years older than me. I remember looking over her shoulder and saying, "What you doing?" She's like, "I'm doing math." And I saw all those letters, and I must have been a bratty kid, because I remember saying, Dad, you're not doing math. That's a bunch of letters." So it really does make students freak out when they start seeing letters in a math class. The average first time failure rate in the nation for Algebra 1, the first time people take Algebra 1, 50%, half of them fail nationwide. 50%. And I put in 1992, that's when I first started teaching, but I've done research and it hadn't changed. Still the same. So here we have x plus 6 equals 10. Now, you may not be teaching them algebra concepts where you subtract 6 on both sides, okay? You may not be teaching that in your grade, but you are saying there is something that we're going to add to 6 and get 10. What is it? And they just know, oh, that's 4. And the same thing. Here's 16 blocks. All right, I want to subtract some to get 9. How many would I subtract? 7. So when you introduce a letter for the first time in a math class, it does freak them out. Okay, let's model subtraction. Okay, so we're going to use concrete methods. Of course, concrete meaning base 10 blocks and that kind of stuff. And then we're going to do equal additions. So an equal additions algorithm. So the main thing to note is that when you guys start teaching with subtraction, most students are used to the addition. So when you put in 257, most students will write down 2 of the flats, 5 of the rods, and 7 little units, okay? But we're so used to adding that students will then start trying to put in, I've got these 4 here, but you don't do that, okay? So when you're subtracting, you only put this first number. That's what you put. That's the blocks that you pull out of your little box, okay? And now we're going to subtract them. So we're going to take away. Okay. Sometimes it's really easy. If I said subtract 3, I would just take those 3 and cross them out. Okay. But it's not that easy because look how many I'm supposed to take away. I am supposed to take away 9. I'm going to go ahead and mark this in blue so that I don't confuse you. Okay, so I've got to take away 9, but do you see that we have a problem? We don't have 9 blocks right here. We only have 7. So we're going to have to take one of these rods. So I'm going to take that rod, I'm going to cross it out, and instead I'm going to break it into pieces. And how many pieces will I have? I'm going to have 10 pieces because we're in base 10, right? Okay, so now we do not have that anymore, but we do have a whole bunch of little dots, a whole bunch of units. So how many units do we have? We've got about, let's see, we've got about, how many? About 17 sitting there. Now we can take 9 away. So I'm going to take 9 away so that the blue ones, that's what did we say, 7, 8, 9. So I'm going to take all of these and I'm going to take them away because we're subtracting. And how many do we have left? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 left. All right, so we did this one. We did our 9 right there. Okay, so now let's take away, let's do this in maybe purple. All right, so now we're going to take away 4 of my rods. So there's my 4 rods. I'm going to just take them away. How many more do I have? None. And then I still have my 2 blocks. So 257 minus 49 is 208. All right, let's do that again with 719. So again, we're going to put 7 flats, 1 rod, and 9 units. Okay, we need to take away 7. Now notice I'm always starting on the right. I'm going to take away the ones first. So I need to take 7 of those away. Do I have 7? I do have 7. So I'm just going to mark them out. So let's see. That looks like about that many. Just mark those out. And I have, 2 left? So I got 2. All right. So now I need to take away 4 of my rods. I don't have 4 rods. So I'm going to have to take one of those blocks and split them into pieces. So remember, that means I'm going to have 10 pieces because I'm in base 10, right? So there's my 10 pieces. So now I can start taking them away. So let's see, I need to take away 4. So I'm going to, I'll do that in a different color. Maybe, maybe a orange. So I'm going to take 4 of those away. Maybe these 4. Take them away. How many do I have left? 1, 2, 3, 4, 5, 6, 7. Got 7 left. And then I still have 6 of these guys. So my answer is going to be 672. So you'll be doing some of that in class. So now we're going to use what's called equal additions algorithm. If you look at the steps down below, you might notice that it looks like the opposite additions algorithm that we did before. So, but this method is a little bit different. We are trying to find the difference between 2 numbers. And that difference doesn't change if we add the same amount to both numbers. So if you remember when we were adding, I added to the top and I subtracted from the bottom. Okay, but when we are subtracting, which is what we're doing here, we're going to be subtracting these guys. You can't just add to both of them because then that, you're just adding more blocks if you think of putting out the blocks. So you can't do that. So whatever you do to one thing, we're going to do to the other. So I'm going to add 3 to the top and get 31. I'm going to add 3 to the bottom So I basically lifted these guys 3 places on the number line, if that might help you to visualize. Anyway, so I got 31 minus 10, and that's a lot easier to do in our head. We don't have to go and break apart any tens and regroup them and all that stuff. So we get 21. Okay. Now you might ask, now, Miss Kitts, why did you add 3 to the bottom instead of adding 2 to the top? Well, look at what we wound up actually doing. We're subtracting. So you want to get those zeros down here on the bottom so you don't have to borrow, right? You want the bottom numbers to be smaller than the top numbers so you don't have to go over here and make that a 2 and trade things out, right? Okay, so here I've got 285, so I'm going to add 15 to get to 200. So whatever I do on the bottom, I'm going to do that to the top. I'm going to add 15 up there as well. So once you do that, then the rest is actually pretty easy to do. You could do that in your head. Okay, so that's called equal additions. So here is an example. Okay, so we have 93 minus 37. So I'm going to add 3 to the bottom. So I'm really going to be subtracting 40. So if I added 3 to the bottom, I've got to add 3 to the top. So I get 96. And then that's really easy to do in our head. 90s, taking the 90s minus 40, I'm going to wind up with 56. So I'm going to do the same thing. If you notice down here, what would I need to get that to the next number up? I just need to add 2. So I'm going to add 2. Excuse me. I'm going to add 2 to the bottom and get negative 40. Subtract 40, and then I'm going to add 2 to the top. So then when I subtract, I've got my 3, and then 32 minus 4, that's going to give me 28. So 283 would be my answer. So that's equal additions algorithm is what it's called. Okay, so the next one is called trades first algorithm. So with that, it's really similar to the old school where you have to borrow, except we're going to do all the trading, all the regrouping first. So what do we need to trade? All right, so I'm looking at this one right here. So that's my 122, right? I've got 1 flat, 2 rods, and 2 ones. All right, I need to take away 7 of these guys. I don't have 7. So I took this one out and I traded it for 10 of these guys. So that's what that is. So I took that and I just broke it into pieces. Okay. So now that's what I have down here. Okay, I just rewrote that down. Now I need to take away, purple, I need to take away 3 of these guys. Well, I got a problem, right? I don't have 3. So I'm going to take this guy and go ahead and trade and get 10. So there's those 10. So I added those 10. So now I have everything I need, so I can go ahead and start taking away stuff. So I'm going to come back in, and now I need to take away my 7. So let's take away 7. 1, 2, 3, 4, 5, 6, 7, and I'm left with 5. Right? I'm left with 5 here. And then here I need to take away, how many? I'll do that in a different color too. I need to take away 3. So let's take these 3 away. And I'm left with how many? That looks like 8 right there. So my answer is going to be 85. Okay. All right. So you might have guessed, I kept saying, oh, so when we break this guy down, we're going to make it, we have to trade it in for 10 because we're in base 10. So now we are going to start subtracting in other bases. Yay. All right, so when we subtract in other bases, notice what I did, okay? So I have I have the same blocks. I've got 3 rods and 2 units. That's my 32 base 5. But notice that these rods, count how many they have in them. Oops, sorry. They have 1, 2, 3, 4, 5. They've got 5 blocks in them instead of 10. Okay, so when I come over here and I need to take 4 of these away, which I do, what I'm going to do is I'm going to break this down and I'm going to add 5 blocks, 5 little units instead of 10 because I'm in base 5. And now I can take away those 4 and take away that one. Whoops, and take away that 1 block. And I'm left with 1 here and 3 there. So I have 13 base 5. I could also do that. I'm going to come back to that. We're going to do that using a chart later on. Okay. So let's go ahead and do this one. I've got 64 base 7. Okay. So these guys, so I've got 6 of those. How many little units did I put together to make just one of those? 7, because I'm in base 7, right? So I've got 6 rods and 4 units. I now need to take away 5. Let me use a different color, sorry. I now need to take away 5 of those units. I don't have 5 units. So I'm going to cancel that out and I'm going to regroup, break it apart, and now I'm going to have 7. 6, 7. Okay, so I have 7 units. And so now I can take away 5 because I have 5 to take away. So let's take away these 5. And how many do I have left? 1, 2, 3, 4, 5, 6. I've got 6 blocks left. Okay. And now I need to take away, let's do it in orange. So now I need to take away 4 rods. Do I have 4 rods to take away? Yes, which is good because I don't have anything to borrow from, do I? Okay, so I'm going to take those 4 away, and I've got this one left. So my answer will be 16, 16 base 7. All right, let's do one more example of base. This time we'll do base 6. So we have 5 rods and 2 units. Again, how many is in each of those rods? I just have 6 units in those rods. Okay, so I'm going to take away, I want to take away 4 units, but I don't have 4 units. So I'm going to come in here, I'm going to borrow, I'm going to take that rod, I'm going to break it into pieces, and how many pieces am I going to put down there? 6, because we're in base 6, right? So now I can come back and take away my 4. They're gone, and I'm left with 4 of those guys. And then I'm going to come in and I'm going to take away 2 of these rods. So those are gone, and I'm left with those 2. So my answer is going to be 24 base 6. Okay, so that is doing it using base, I said base 5 blocks. That's base 5 for this one, but we used 7 on this one and we used 6 on that one. So we just use our blocks to do that. But now we're going to work these same exact problems, but we are going to use a chart because you may not always have the blocks with you. Plus, just like our professional told us, we need to move from the concrete to the abstract, okay? All right, so we've got 32 of our, in base 5, so we've got 3, think of it as 3 rods and 2 units, but I need to take 4 away, but I can't because I only have 2 there. So I need to cross out this and I'm going to make it 2. And then how many units, when I have this rod over here, how many's in there? We've got 5 because we're in base 5, right? So we're going to add 5 to that. So when we add 5 to that number, we're going to get 7, right? So we're going to say 7 minus 4 gives me 3. All right? And now let's go over to the 5s, okay? So, and 5s, think of that as 5 to the 0 and 5 to the first, because that's what this guy is, right? That's got 5 in my rods. So anyway, 5 minus 1, 2 minus 1 gives me 1. So my answer is going to be 13 base 5. That's what we got up here, right? All right, now let's do the same thing here. We're going to set it up. Notice this is base 7. Base 7. Oh, hello. I'm sorry about that. So here is base 7. All right. So we're going to have 7 to the 0. That's the 1's place. And this is, we would say the 10's place, but it's the 7's place, right? Because it's 7 to the first. Anyway, so we got 64. We got to subtract 45. Unfortunately, we only have 4 here, so we can't take 5 away. So I'm going to come in. I'm going to cross that out and make it a 5, right? And then what are we going to add to the 4? We're going to add 7 to it because we're in base 7. So that's going to give me 11. So 11 minus 5, that's going to give me 6. And then we're going to just subtract my 5 minus 1 right there. 5 minus 4 and get 1. So I'll have 16 base 7. That's what we got up here. All right, last one. Now we're in base 6. So we have 52. We want to subtract 24. And once again, you cannot actually take 4 away from 2. So we're going to exchange. So we're going to take that rod, break it into pieces. How many pieces would be on that in that rod? 6, because we're in base 6. So I'm going to add 6 to it. That's going to give me 8. So 8 minus 4 is 4. And then 4 minus 2 will give me 24. So I'm going to get 24 base 6. We are almost done. We're going to do some mental math now. So same thing that we've done before, breaking and bridging and dropping zeros. So it's exactly what you did in addition. It's just we're going to be subtracting those guys. So notice here, we broke 47 into 40s and 7. So we're going to take our 40 away from 98 and get 58. And then we take our 7 away, and that gives us 57. 51. Sorry about that. Okay, so, all right, so the next one, we've got 67 minus 36. I'm going to break that 36 into 30 and 6. So I'll say 67 minus 30, which is going to then give me 37. So 67 minus 30 is 37. Then I subtract 6 more. That gets me to 31. One last one. 189, I'm going to subtract 50 first. So that would give me 139. And then I subtract my 7, and that gives me 132. And then dropping the zeros, exactly what it sounds like. I've got 5,700 minus 600. So I just think of it as 57 minus 6, which is 51. And then I just add my zeros. So 5,100. Same thing here, 28,000 minus 5,000. Just think of it as 28 minus 5, and then add your zeros. So we finished doing section 3.3, our subtraction of whole numbers. You should be able to do all of the working together worksheets in class.